Figures 10.4 through 10.9, member initializers used to initialize a constant of a built-in data type. In these figures, we're actually going to look at two versions of the same program, one that implements initialization of a const data member correctly, and one that does not, so that we can show you the compilation errors that you receive. Here we have kind of a mechanical class called increment. In the private part of the class, we have an integer called count, and we also have a const integer called increment. Now, when you declare constant members inside of your class, those members have to be initialized in a very specific format using what we call a member initializer list in the constructor definition. So we'll take a look at that in the source code file in a moment. Now, in the public part of our class, we have an increment constructor which receives two integers, one that initializes the count and one that initializes the increment. 0 and 1 are the defaults for those. And then we have an add increment member function that just adds the increment to the count, and we'll just demonstrate this by calling it a few times in our main program. And we have a print function that's going to display the values inside of an increment object at a given time. Now, the key feature in this example is the implementation of our increment constructor and the introduction of what's called the member initializer list syntax, which occurs between the end of the parameter list of the constructor and the beginning of the constructor's body. And actually, this is the appropriate point at which to initialize all of your class's data members when possible. And I say when possible because sometimes more complex initialization is required that can only be done in the body of the constructor. So here we purposely have an empty body because both the count and increment data members are being initialized in the member initializer list. Now, the member initializer list is introduced by the colon followed by the name of a given variable that you want to initialize, and then in parentheses you can have its initial value. So for the count member, we're going to initialize it with the C parameter, and it's a list because we have commas separating the items being initialized. So because we have more than one item, we put a comma, and then here on the next line we're saying to initialize the increment with the value I. Now, for the count member, which was not declared to be a constant, we don't have to actually initialize that here in line 12. We could have simply said count gets C inside the body of the member function. However, when you have a const piece of data, the member initializer list syntax is required for that piece of data. Otherwise, you will get a compilation error, as I will demonstrate in the second version of this program in just a moment. Now, the print function is pretty straightforward. It's just going to output the count and increment values and then a new line and flush the buffer. So for the purpose of this example, we just want to work with our increment object. We create an increment object called value that starts with the value 10 and has a constant increment value of 5. Before we do any incrementing, we print the value, and then we iterate 3 times, and each time we call our add increment, which just adds the constant to the count non-constant variable, and then we display after increment j what the values inside the object are. So again, just a mechanical example here to demonstrate this concept of constant data members. And as you can see, increment is always 5, and our count is increasing by 5 each time we increment it. Now, let's go ahead and remove these files from our project, and I'll add the files from the next program, which is basically the same program again. And here the difference is actually in the implementation of the increment class. So you see the same increment class header file. The difference is in increment.cpp, where we are no longer properly initializing the increment const data member of our class. And you can see that we're getting an error message. It says expression must be a modifiable L value. Increment is a constant, so we can't use it in an assignment statement like the one on line 14. We also have another error message being reported at the opening curly brace indicating that there's no initializer provided. So if I run this in through the debugger, we can see the error messages down here. It's telling me that the increment data member of the increment class, notice lowercase I and capital I, must be initialized in the constructor base/member initializer list. It's telling you explicitly what needs to be done, and in this case, if we were to modify the code and say :increment, left parenthesis I, right parenthesis, and let's comment out the bad increment line in line 15. So you notice my error message squigglies go away now, and now if I try to build this solution, you'll see that it builds successfully. So here is what the constructor would look like if you were only initializing the constant piece of data in the member initializer list, and then, as I said, you can always assign counts value directly in the body of the constructor. Now, as we will learn as we go forward and start talking about concepts like building objects of other classes into a new class that you're defining, you're going to see that sometimes there are other cases rather where this member initializer list is required, and in most cases it's a good programming practice to initialize all the data inside an object of your class, if you can, inside the member initializer list. So we'll be talking about this syntax repeatedly over the next over this lesson and the next several lessons as well.